Hey everyone, I hope you're all doing well and thanks for tuning in to another video. In this one, we'll be building a complete CRUD API that connects to a DynamoDB table using API Gateway and AWS Lambda. Our Lambdas will be written in Node.js using the latest V3 AWS SDK. And of course, we'll also be using the serverless framework as well as GitHub Actions for our deployment pipeline. So hopefully you'll find this video useful, and as always, if you have any ideas or suggestions or something you want to see, feel free to drop a comment below. But for now, let's dive right in. Now, the first thing we'll be doing is setting up the deployment configuration as well as the IAM policies. So we're going to go ahead and head over to the IAM management console, and we're going to go ahead and create a new user. So I'm already on the page. I'm just going to name my new user DynamoDB CRUD API user. Feel free to name it however you wish. And we're going to check off programmatic access only because we need the access keys. So we're going to click that, and we're going to click attach existing policies directly. And now this is going to be a bit tedious, but we're just going to go through this list in order. So the first thing that we need is IAM full access. This gives us access to IAM permissions. And we also need S3 full access. This is also part of the serverless framework, in which basically what the serverless framework needs to enable a successful deployment. Because this video we're working with DynamoDB, we would also like DynamoDB full access. We also need CloudWatch logs full access. If I can find it here, there it is. Okay, and we also need API Gateway Administrator because we'll be working with that as well. And we also need CloudFormation. And last but not least, we need AWS Lambda full access. So I'm going to go ahead and check that off. Awesome. So we can just skip the tags part. Just review that we have everything. Awesome. Okay, this looks good. So we can go ahead and click Create User. Okay, awesome. So now we are faced with a one-time presentation of the secret access key. So we're going to go ahead and copy that. And now we're going to go ahead and head over to our GitHub repository and click into Settings. And we're going to scroll down into Secrets. And we're going to add a new repository secret. Now I'm just going to call this AWS secret access key, and we're going to paste that in and add the secret. We're going to also add another secret, and this is going to be the AWS access key ID. And this one we can always view it under IAM. So we're just going to go ahead and copy that, and we're going to go ahead and paste it in. Awesome. Be careful of any white space at the end or at the beginning. But yeah, awesome. So once that's done, we can actually go ahead and write our GitHub Actions configuration file. So we're going to go ahead and open up our favorite editor. I'm just going to use VS Code in this case. And because the configuration file for GitHub Actions in terms of all these serverless projects is going to be the same across many of my other serverless projects or tutorials in the series, I'm just going to use the same file that I've pre-written. So if you haven't watched the other videos, I'll also quickly go over what's going on, just so we're not totally out in the dark here. But basically, we're going to create a folder in the root directory called .github, and within that folder, we're going to create another folder called workflows. And within this folder, we'll finally create a file called main.yaml. I'm naming it main.yaml just because I'm going to be deploying on the main branch. Or sorry, this job is going to be triggered on the main branch. So basically, this is a file. I've already pre-written it, so I'm just going to paste it here. But just to quickly go over what's going on, we're specifying a name here. We're also specifying that this job will only be triggered or be executed when we push to the main branch. And the job is just going to be called deploy. We're choosing the operating system of which we're going to be executing this job. We're caching our node modules using node version 14.x. And of course, we're installing the dependencies. And last but not least, we'll be running serverless deploy, which allows us to deploy our serverless project using the serverless framework to the AWS cloud. And this is where we actually get to use the secret or the access keys that we have generated earlier on. So with this out of the way, we can finally go ahead and install all the dependencies that we need for our project. And before we just run the command to install our dependencies, I'd just like to quickly go over why we're using the version 3 AWS SDK as opposed to version 2, which is what most of people are used to. So the reason why is because version 3 is built to be highly modular. And what that means is that instead of installing the entire AWS SDK, which we would have to do in version 2, we only have to install the single one along with maybe one or two like sub-modules that we might need to complete our use case. Basically, we only need to install what we need, and this will help us greatly reduce our Lambda package size and ultimately increase performance in things like the deployment time and whatnot. So overall, it's just a great way in moving forward. On the documentation page for the version 2 AWS SDK, they also recommend you to use version 3 as well. And if we actually take a look at the package size here, version 2 is incredibly large because it basically covers all AWS services. So it's around like 62 megabytes as opposed to just the client DynamoDB package submodule that we need. This is only around like 4.5 megabytes. So you can see the incredible size difference. So yeah, this is why we're using version 3. We'll also be using or installing the DynamoDB utility functions or methods. In this case, this one only has or only provides us access with Marshall and unmarshal. And basically, these functions allow us to convert back and forth between JavaScript objects or JSON into DynamoDB records. And the reason why we need this is because if we take a look at this example here, this is just a Stack Overflow post that I found. But basically, this gives us an example of what a DynamoDB record might look like. And we'll, of course, definitely go through this more in detail when we actually deploy our functions and test them. Basically, the DynamoDB format has a separate nested key within that specifies the type, the data type of the value it's going to be storing. So S stands for string here. And basically, it's just in a different format as opposed to JSON. And those functions will help us convert between this and regular JSON. So yeah, that's why we'll also need that as well. And last but not least, we also need the serverless.ym roles per function plugin. And basically, the reason why we need this is because for our project today, we'll be creating multiple endpoints, and each endpoint will have a separate Lambda handler. And it's a really good practice to ensure that each Lambda has a highly restrictive set of IAM permissions and basically allow a set of access rules in terms of what it can access on the AWS cloud. And it's because each Lambda will be performing a different operation, for example, like reading or getting or adding things to the database, we want to ensure that each Lambda will only do those things and nothing else. So that's just a good practice. And this serverless plugin will allow us to basically specify a really granular set of rules for each Lambda. So with all that explained, let's go ahead and actually write up our serverless.yml configuration file. So in our root directory, we're going to go ahead and create a file called serverless.yml. And the first thing we want to specify is the service name, or basically our project name. And this is going to be a DynamoDB CRUD API, so I'm just going to name it as such. And we also want to specify the cloud provider that we'll be using. In this case, it will be AWS, and the runtime for our Lambdas, which is Node.js 14.x, which is currently the latest version supported on AWS Lambda. We also want to specify the stage for development. I'm just going to use dev here because we're still in development. And we can also specify the general region of which our resources would be deployed. I'm going to be using US West 1. Preferably, you always use the region that's closest to your clients of service. The next thing we want to specify is the global environment variables that, so we're going to specify under the environment field. And I'm just going to create a variable called DynamoDB table name. And essentially this will help us store the DynamoDB table name, which we can then access within our Lambda functions themselves. And so to do this, I'm actually going to be creating a custom variable later on in a second. But I'm just going to reference it here first as self:/custom.post table name. So if you can guess already, basically our DynamoDB table for demonstration purposes will be holding like article posts for like a blog or something. Of course, your use case will be unique to yourself. So yeah, now we're going to go ahead and create the custom field. And of course, this is going to hold our post table name. And I'm just going to call this post-table and dash. I'm also going to include the stage as well. So we can have a unique table for each stage if we choose to move further along the development process. So yeah, next thing we need is, of course, the plugins. And we only need one plugin here, which is, as mentioned earlier, the serverless.ym roles per function plugin. So we can just list it as such. And awesome. And once that is out of the way, now we can go ahead and basically write the configuration to deploy our actual DynamoDB table. And this is going to be under the resources field. And basically under here, we can actually declare CloudFormation templates directly. I'm going to be using in YAML format, of course. And yeah, so we can now specify the deployment configuration for our DynamoDB table. So it's going to be as follows. We're going to create a field called post table. Basically, it's going to be for our project, or for demonstration purposes, at least in this tutorial, we'll be creating a table that will store a set of, like, I guess, user posts for maybe like a blog or blogging service or something like that. Of course, your use case will be unique to yourself, so feel free to name this to however you need. I'm just going to call this post table here. We're also going to specify the type of resource this is going to be, and of course, this is going to be AWS Dynamo, oops, too many colons there, DynamoDB : and table. Awesome. And of course, we also need to specify some properties here. So namely, the first thing we need is, of course, the table name. This is the actual table name that will appear on the AWS cloud, as opposed to the field here. So for the table name, we've already declared it here in our custom variable, so we're just going to reference it there as such, custom.postName. Oops, too many curly braces. All right, and the next thing we need is the attributes definition. So for the next two fields, I'm just going to quickly write them out first, and then I'll explain them in a second, what's actually going on. But basically here we're going to create an element in the list called post ID, and we're also going to specify the type of this element, and I'm just going to keep this as a string. You can also, if you want your IDs to be like numerical, you can just specify this as n for number, but I'm just going to keep it as strings. And of course, after that, we also need another field called key schema. And again, I'll explain this in a moment, but under key schema, we're going to create a new element, and we're going to call this attribute name. And of course, it's also going to be post ID, and we're going to specify the key type field for this, and it's going to be hash. All right, so basically what's going on here is that the attributes definitions field is going to specify an array of attributes for describing the key schema for the table, as well as the indexes. And what I mean by key schema is basically the field here, and this specifies the attributes that make up the primary key of a table or the key attributes of an index. And basically what that means is that we're specifying the primary key of which we will be, for example, looking things up in the table, and basically, looking things up in the table so that we can uniquely identify documents within the table. And yeah, the last field that we actually need is basically specifying the provision throughput, and this allows us to specify how much throughput we want to allocate in terms of reading and write operations. And I'm just going to keep this at the very bare minimum, which is just 1. So I'm going to keep it as 1. And of course, we also need to specify the write capacity units, and we're also going to specify that as 1 as well. And I'm just checking if I made a typo here. Okay, awesome. So once that is out of the way, we can actually go ahead and write our functions configuration. So I'm just going to include this above the resources field. All right, so the first thing we want to do is, of course, put this all under a functions field. And the first thing we want to create is our get endpoint. So I'm just going to call this get post. And we're going to specify our handler path, or where our Lambda handler is going to be. In this video, to keep things simple and organized, I'm going to put everything under the API.js file that we'll create in a second. If you want to refactor it, feel free and definitely do so. But yeah, so I'm just going to create this on an API.js file, and I'm going to call my function get post later on, and we can specify the name of the function, and it's just going to be called get-post. You can also include a description. I'm just going to leave that out for now. We also want to specify the memory size, because the documents we'll be working with today are going to be quite small. I'm just going to use the minimum value possible, which is 128 megabytes, and I'm also going to specify a timeout of 5 seconds. Awesome. All right, so the next thing we want to specify is the event triggers, and basically this is going to be a set of events that actually allow our Lambda function to know when to execute. The specific one we want is going to be HTTP event triggers, which is basically like when someone makes an API request to our endpoints, then our Lambda function will be triggered. And so two things that we need to specify under here are the endpoint path, and it's going to be post slash and curly brace post ID, and we're going to basically, this is allowing us to specify path parameters so that when we actually call this endpoint, we can just pass the post ID and a path parameter as opposed to the request body, since this is, after all, get endpoint. And yeah, so the so under the method field, we're gonna specify get as the HTTP method, and awesome. Now the next field that we can specify is it's gonna be the IAM role statements, and as mentioned earlier, this is basically specifying the permissions that we have for this Lambda function specifically, and it all follows the same format. It's gonna be it's gonna be an element into the list, and it's gonna be the first field is gonna be effect, and we're gonna be allowing the following action. and the action is going to be DynamoDB :get item, and it has to be in this format. We also want to specify the resource of which we will be allowing this action on, and the resource is basically going to be this DynamoDB table that we will be creating together. And to access that, there's a special function. I believe it's called a function, I guess. It's basically get attribute, I believe. But basically with this, we can reference the ARN, basically the Amazon resource name of this table once it has been deployed. And the ARN basically allows us to identify which table among all the tables perhaps in our region and AWS account that we are referencing. So we're going to go ahead and type that in as post table, and that's basically referencing this field here, and we're going to get the attribute of that .arn. So we're going to specify as such, and you'll see this this really similar format for basically all the other Lambda functions as well. So now we can go ahead and move on to specifying the configuration for our create post function, which is basically our post endpoint. And of course, it's all going to be under the api.js file. I'm just going to call the function create post. So create-post as well. Memory size is going to be really similar, 128 megabytes, and timeout. Timeout is going to be 5 seconds. As you can see, it's going to be get a bit tedious here, so I'm just going to start copying and pasting a lot of this. Often a good practice in software engineering. So I'm going to paste that in. Of course, we want to make sure we change the HTTP method here, and because it's a post endpoint, we'll be attaching a request body, so we don't need the path parameter, so we can remove that safely. And one thing to note here is the action. We got to change this, so we're going to change this to put item as the action for the post endpoint, and of course, the resource is going to stay the same. After that, we can copy. My copy and pasting didn't work there. After that, we're going to copy this entire thing. And we're just going to paste it again because it's going to be really similar for our put endpoint. So I'm just going to call this update post. Trying to keep this quick. Memory size timeout is going to be the same, and this is going to be a put endpoint. And because this is a put endpoint, I guess it doesn't really matter. I guess it's up to your preference, but I'm going to keep this as the post ID as a path parameter for the put endpoint. But yeah, feel free to modify that or change that as you wish. So yeah. One more thing that we need to change is, of course, the action once again. In this case, we're going to be using update item. I believe you can also use put item. They have really similar rules. So if you want to read more about the documentation on that, it's definitely available. I'll probably drop a link down in the description below as well. But we're just going to use update item since that is, I believe, the one meant for put endpoints. So we're going to keep it like that. Okay, and I forgot I uncopied that, so I'm going to recopy this. Okay, and the second last endpoint that we want is the delete endpoint, or I guess the last endpoint in the set of CRUD endpoints. But basically, this is going to be a delete post. I'm just going to quickly change that. And of course, the delete endpoint, we do want to keep a path parameter as a post ID because we don't need any request body for this. So we're going to keep that there. And as for the IAM role statement action, we just want to change this to delete item instead of update item up there. And the resource is going to stay the same. Awesome. Okay, so the last thing that I want to do is actually create a separate separate Lambda handler and basically endpoint specific for demonstration purposes. This is not going to be a production ready Lambda, but basically this is going to be a get all post, so like a batch get retrieval endpoint. So I'm just going to call this get all posts, get all posts, I guess. Awesome. Okay. But basically, this is going to be for demonstration purposes later on so that we can actually just quickly see all the posts that are available in our table. But you don't have to include this if you don't want to, but I'm just going to include it for now. And of course, we're going to change the resource path to post because we are getting multiple things at once. And this is going to be get again. And be careful here because we're getting multiple things. The action we want to specify is not get item. It's actually going to be scan. Essentially, we are scanning the DynamoDB table. Okay, awesome. So we can just quickly hit save. And that's pretty much it for the serverless configuration file. Thank you for following along. I know it's a bit tedious, especially with all the lambdas that we had to configure. But yeah, since this is done, we can actually go ahead and start writing all our lambda functions and writing some code. I apologize. I actually realized I made a small mistake. So I actually paused the video before I move on to subsequent sections, just so I can review things like the file that we wrote together, in case we made a mistake. So the mistake that we actually made here, which is actually pretty important, is that attributes definitions, it's not supposed to be plural here, it's just singular, so attribute definitions. So just be careful about that. But yeah, we're just gonna quickly save that and move forward. All right. Okay. So the first thing we want to do now in terms of writing our code and setting up our lambdas is create a file called db.js. And basically this is going to help us instantiate our DynamoDB client. And yeah, so to proceed, we're going to, not withdraw, my bad. We're going to extract the DynamoDB client constructor here from the module that we have imported earlier. Or sorry, oh, my bad. I actually haven't installed all the modules yet, so we'll just do that in a second. I realized I explained it earlier, but I never actually ran the command to install them. But anyway, we're going to instantiate the client by doing calling new DynamoDB client. And I guess you can just pass in an empty object. We don't actually need to specify any arguments here because this is all going to be under a serverless application. But one thing that we do need is, of course, to export this client so that we can use it in our API.js file later. But one thing that we're going to do now is just quickly install all the necessary dependencies. I'm going to be using Yarn. Feel free to use npm if you wish. But basically, the first thing we need is at ampersand. Sorry, this is not ampersand. At AWS-SDK client-dynamodb. We also need at AWS-SDK-util.dynamodb. I'm just trying to make sure I spell all of this correctly. And last but not least, we need serverless.ym-roles per function. Function. Awesome. Okay, so I'm going to wait for this to install. Once that's done, we'll be back. So we're back and all our dependencies are finally installed, and because they've been installed, we actually need to quickly create a git ignore file and just ignore all the node modules because we definitely don't want to commit all of that. So this should update in a second, I believe. Okay, awesome, it's been updated. It took a while. Okay, so now we can actually move on to writing our Lambda functions. And as mentioned earlier, this is all going to be under a file called api.js, so I'm going to name it as such. And now the first thing I want to do is import the database file that we have specified just now. So require./db, and we also want to import the set of commands that we need for basically communicating with our table. So we're going to first basically import the correct module, and this is going to be client DynamoDB. I'm going to specify the commands in a second. The other module that we need, which is going to be providing our marshal and unmarshal functions, is going to come from the util-dynamodb module. Awesome. Okay. So because we're using version 3 SDK, the format is a bit different than version 2 if you've worked with version 2 SDK functions before. Basically, the way we're going to do this is we're going to actually import a set of commands, and we will be sending these commands using the send function, which we'll see in a second. But basically, the commands that we want to import are going to be, get item command. I'm not sure why it's not highlighting it right now, but I guess we'll just type it out. We also need put item command. We also need delete item command. So basically, as you can see, there's basically a command for each of the operations that we have for our endpoint. So scan command and update item command. Awesome. Okay, so once we've imported all 5 commands, we can now start to write our handlers. All right, so the first handler we're going to create is our get post. I'm just going to go off the order I've specified them in the serverless.yml file. It's going to be an asynchronous function, and we're going to pass in the event, the Lambda event, as an argument. The first thing we want to do is create the response variable. Basically, this is going to be the response that we'll return for our endpoint. And the first thing we want to specify is our status code. Sorry, this is not the response that we'll return from the endpoint. It's going to be the response that we return from the Lambda function. And the body will be what's going to be returned by our endpoint. All right, okay, so the next thing we want to specify is, of course, our try catch statement or block. Basically, this will allow us to handle all the errors that may arise when we try to retrieve the post. Inside the try block, though, we're going to create a variable called params, and this is going to store all our retrieval parameters, the first of which is going to be the table name. And because we specify in our serverless.yml file earlier that our table name is going to be accessible in an environment variable, we can access it as such. So it's going to be process. I'm not sure what's doing that. Sorry. My IntelliSense is not working correctly today. But anyway, process.env.dynamodb table name. All right, awesome. So once that is specified, we also need to specify the key, and this is going to be an object holding basically our primary key, or the key of which we're going to be searching for the post, which in this case just happens to be the primary key. And this is where we need to marshal our key, because we're going to be passing a JSON object or JavaScript object in general. And it needs to be converted into a DynamoDB record in order for it to recognize that it's a proper key. So we're just going to pass the JSON object within the marshal function. But basically, we're going to specify the post ID field, and we're going to extract the post ID from the path parameters under event.pathParameters.post ID. Awesome. Okay, just put a comma there and semicolon there. And now we can actually try to call the function to get the post. And this is the item is going to be available under the item field. So I'm just going to deconstruct that. And we're going to, of course, await on this call. And it's going to be db.send. And remember, db is the client that we have instantiated earlier. So it's going to be basically the client function module. And we're going to call the send function. And we're going to create a new version of the get item command. And we're going to pass in the parameters in there as such. This is just the syntax of the V3 functions and how they're supposed to be used. And you'll see this in a second, that it's going to be really similar for all the other commands later on. Awesome. So once this is basically, once we have retrieved it, I guess we can do a quick log. We can just say, I guess we can just log the item in an object, I guess. Awesome. Okay. And of course, we need to return it. And this is going to be under the response body. And because we are using a Lambda proxy integration, we need to make sure that the response body is stringified. So just be careful of that. We can also include a quick message into the response body as well. So we can just say successfully retrieved post and the data, which is going to be our item. And I guess here we need to check actually if the item exists. So if the item doesn't exist and we couldn't find anything, this will actually be undefined. So we need to make sure that it's defined first. And if it is defined, then we call the unmarshal function and pass in the item. And this will help us turn the item back into a JavaScript object or JSON object so that we can return it in the response. But if item is not defined, as in we didn't find anything, we'll just set it as an empty object, and we don't need to unmarshal that or anything. Awesome. And then if we want to see the actual item itself in DynamoDB record form, we can just include that in the response as well. So you can see the difference between the two. All right, and so for the catch statement, I guess we can just include a quick error message to log it. We also can set the status code to 500, server-side error. And of course, we also need to specify the response body. And we can just change this to, I guess, fail to get post as the message. And we can include fields such as the error message field. Of course, none of this is necessary none of this is necessary, but as good practice, it's nice to see what went wrong, especially when you're debugging. So I'm just going to include this, and feel free to use it in your code as well. So we're logging the message as well as the stack trace of the error that was generated. And awesome, that pretty much wraps it up. The last thing that we need is, of course, to return the response object. And yeah, so that's pretty much it for the get post Lambda handler. And now we can go ahead and copy most of this and proceed with our create post Lambda handler. So I'm going to paste this in. I'm going to quickly rename that to create post. A lot of this is going to stay the same. Of course, the body, the request parameters are going to be a bit different because we're going to be doing a different operation here. One thing that we do need here before we modify the parameters is actually we're going to parse the event body, and basically this is the request body that we will be storing into our database. So the post itself and all its properties and whatnot. We also need the table name for the parameters, But instead of key here, because we're not trying to search for anything, we can just specify item, because this is going to be the item that we want to store into the DynamoDB table. And similarly, again, we also need to marshal this because we're going to be taking in the request body, which is going to be coming in as JavaScript or JSON format. So we can actually just pass this in, and if it is defined, I guess this is just some error handling. If the body is defined, pass it in. If it's not, we'll just pass an empty object. I guess maybe you might not want to store an empty object depending on your use case, but yeah, this is just how I'm going to code it up. Feel free to modify this as you need. The next step here is we're going to change the command that we're actually sending. Obviously, we don't want to get anything here. The result, we don't need to deconstruct anything, so we're going to change this to create result. We also want to change the command to put item command, and we can keep this as parameters, which is what we're going to be passing in. All right, we can delete this log here, and we can also keep most of the response body messages. So successfully created post, I guess we can just change that. The data, we don't really have any data because we're not retrieving anything, so we can delete most of this. But what we can return is also the create result, just so we can see what's being returned by DynamoDB. Awesome, and we can just quickly change the message here as well, fail to create post. And the rest can stay the same. So as you can see, that was pretty quick. We just had to modify a few things here and there. And yeah, now we can copy this function and proceed forward with our update post or put endpoint Lambda handler. And to get this started, we can just quickly rename this function to update post. And there are actually a few things we need to change for the update function, which we'll go over in a second. But first things first, besides the event body, which is going to be the request body that we're going to parse, we also want to create a new variable called object keys. And basically, we're going to obtain all the keys from the request body. And we're going to use this in a second. We also will not need item because we're not adding a new item to the database. We're simply updating an existing item. So we need to actually find the item we want to update. And so we're going to use the key field instead. And if you recall from earlier, when we use key, we need to make sure we marshal the JSON object we pass in that holds the key. And in our case, we only have one attribute that is going to represent our primary key or the key that we're searching by. And that's going to be post ID, which is passed in the path parameters of the endpoint. And it's going to be called post ID. Awesome. And so the next part, this is where it gets a little tricky. This part uses something called the update expression, which is specific to DynamoDB. And basically, what it is that it's like a special string expression that allows us to perform updates onto existing documents in the table. And ideally, I've pasted it here. I've pre-written the example. We can just go over it. But basically, here, this is, for example, if they had like an attribute called session ID to store their session ID. This is the expression that we want. There are different variations of it. For example, you can have set, you can have remove. In this case, set will only allow us to add or modify existing attributes. So essentially, we'll not be able to delete any existing attributes from any existing documents, but that's fine. Depending on your use case, you might need to tweak this a little bit, but I want to keep it simple without adding too much logic. The other field we need is expression attribute names. Basically, this specifies the attribute name. And of course, we also need the expression attribute values. And this just holds the type and the string, the value itself. So ultimately, we want to obtain this format, but because we don't know, we want to keep things dynamic, we're going to have to write some code. I actually obtained this solution from a Stack Overflow post and just modify a little bit. So I'm just gonna paste that in here to save us all some time. And I just want to make a quick note. The reason why they're using a pound sign here is because DynamoDB obviously has its own set of reserved keywords. And this basically allows us to escape it. So depending on your use case and depending on how you name this key value here, or essentially this value here, you might need to escape it by using the pound sign. The rest is just the convention and the format that they want you to follow. So yeah, I'm just going to leave it like this. Feel free to read up more on the documentation if you would like, but I prefer for now just to move forward so we can speed things along a bit more. But awesome. So once this is done, we can go ahead and actually make the call to perform the update. And instead of create result here, we can just call this update result. And of course, changing the command to update item command. And we're just going to pass in the parameters as usual. And for response body, our message is going to be a bit different. We can say successfully updated the post, hit save. As for the error message, we can just say fail to update post. And I guess, yeah, the rest should stay the same. Awesome. So once this is done, we can actually go ahead and copy this once again and paste it below so we can write our delete Lambda handler. So I'm just going to call this delete post. Awesome. Okay. So as for the delete Lambda handler, we don't need a lot of this update expression stuff because it's not that complicated. It's pretty much like the get endpoint. We're just going to get the post ID from the path parameters as we have specified earlier. We don't need to get the keys from the request body. We don't actually even need the request body at all because we're, sorry, I'm trying to highlight the whole line there, because we don't need to basically update anything or pass anything into the database. We're simply deleting it. So we just need the post ID and parameters, and then we just need to change the command to delete item command, pass in the parameters, and that's pretty much it. We'll just change the name of this variable here to keep things consistent, delete result, and we can just paste that in. And we can just say successfully delete a post, failed to delete post. Awesome. Okay, and that is pretty much it for the delete post. As you can see here, copy and pasting is really helping us save the day. Of course, there's probably refactoring optimizations we can make here to prevent duplicate code, but I'm just going to paste this out here so that paste them all out individually so that you can feel free to modify the code yourself, fork the repository, and just like twink around with it to however you need. But last but not least, what we need to do is create our get all post function, and this essentially will perform a scan on the database and get us all the necessary values that we desire. And basically what we want to do here is we don't actually need a parameters object here, I guess. It's a little bit redundant or a little long. We can just keep it simple. But what we want to do is deconstruct the result and get this field called items and make sure that it's items plural, because after all, we're getting multiple items at once, or at least an array of them. And then the command that we will be sending is called a scan command, which we have imported earlier. And as for parameters, we can just create a simple object here because we don't actually have a key or anything. We're just scanning the entire table. All we need to specify is just the DynamoDB table name itself. So we can leave it like that. Awesome. And that's pretty much it. So one issue with this get all post function that I want to bring up, and which is the reason why I was hesitant about actually including it in this video, is that the way that the scan command works is that there's actually a threshold in terms of the amount of data and its size that it can return in one function call. I forgot the limit. Maybe it's like a 1 megabyte or something like that. But the one way to circumvent that, or basically fix that issue, is to use one of the fields that are returned by its output, and that field is called, I'm just going to type it here, last evaluated key, I believe. So it should be a field returned by the scan command, and basically that will allow you to perform multiple or subsequent scans based off of where you left off. So yeah, if you have a huge table with many documents, you will need to do that and pretty much fix this function. But because we're not going to be inputting a lot of stuff, I'm just going to make one scan call, and that should be sufficient for our use case for now. But just keep in mind, this is definitely not an ideal function. This is just for demonstration purposes. But yeah, just small things here. We can just quickly change the message once again. Successfully retrieved all posts, I guess, and failed to retrieve posts. Awesome. And once again, this part here, because we are retrieving posts in items, we need to unmarshal this again, because it's going to come back as DynamoDB format. So we're going to go ahead and turn every single element items into an unmarshaled, or basically a JavaScript object. So to do that, we can do items.map, and we'll just pass the item into the callback, and we're going to return the unmarshaled item. Awesome. So that is pretty much it. As for the data field, of course, you can also log items in its raw form as well. So I guess we can do that. Yeah, and we can go ahead and take a look at what it looks like when we test the endpoint. And awesome, that pretty much wraps up all our Lambda handlers. One thing that we do need to make sure we include is to export all our functions just so that they have access. So I'm just gonna quickly shorten everything here. I apologize. You can skip ahead right now if you'd like. But basically, I'm just gonna copy and paste all of these so that we don't make a typo or anything. And I'm gonna export all of them. And awesome. Okay, so once all these are exported, now we can finally move on to deploying the entire project basically, and then we can go ahead and test all our endpoints. So we're back, and the deployment has finally succeeded. As you can see, all the steps in the GitHub Actions workflow have succeeded. And so we can go ahead and head over to API Gateways console, and you should be able to see your API listed under APIs. And if you want to head over to DynamoDB as well, you should also see your table having been created here. Awesome. So if you want to, we can just quickly validate that there's actually nothing in our table right now, no items here. So now we can actually start to test our endpoints, and to do so, a quick way to get the base URL is to just go under stages on the left side menu and click into dev, and this will essentially get us our base URL of our endpoint. If you want the actual endpoint itself with the altogether, you can just click into it and then copy that as well. So I'm going to be using Postman here to test it. I hope this is large enough. I've actually already pasted it in here. As you can see, it's the exact same one with the same ID, just for demonstration purposes and to speed things up. And I'm just going to click send to show that there's no post with post ID of 1. This is the batch endpoint. There's no post at all right now. And now we can go ahead and actually just quickly create one. I've tested it earlier just to see if it works. And we should create a new one. I'm not sure why that took so long, but anyway, it has succeeded. So we can quickly use the get endpoint. As you can see, the result, we get both the JSON version, basically the unmarshaled version, as well as the marshaled version, which is the DynamoDB copy or format version. And as you can see, the format is pretty different, which is really great that we have these unmarshaled and marshaled functions, utility functions provided for us. Otherwise, we would have to format this ourselves. But this is what it looks like. If we use a single endpoint, just querying on post ID of 1, this is what we get as well, just a single object as opposed to an array of objects. But yeah, if we go ahead and try to update this, I'm going to copy this request body here and use it in our request body for the put endpoint. And be careful, because of the way we implemented this, we're going to be passing the post ID as a path parameter and not the request body. So we need to remove this actually, otherwise it will throw an error because you cannot be updating the primary key like that. Now we can go ahead and hit send. Actually, sorry, we haven't actually updated any information, so it wouldn't appear as if it updated. So I'm just going to put like no author here maybe, and change the views to like 10,000. If we hit send, this should successfully update. And if we just go to the get endpoint, we can see that the author and the views have updated, but everything else stays the same, which is the exact behavior we have specified. And yeah, just to wrap this up, I guess we can just quickly delete this. So we can hit send on our delete endpoint of post ID 1, and it should successfully delete it. And if we try to retrieve it again, it is clearly gone. And yeah, that's pretty much it for this tutorial. Kudos to everyone who stayed to the end. I know this tutorial must have been a pretty long, but I really hope you learned something or found this video helpful. And if you did, please do consider hitting that like and subscribe button down below, as it really helps with the channel and series an incredible amount. And as always, I hope you're all staying happy and well out there. But for now, take care.